Welcome back to linear algebra. Let's jump in donkey. All right, here we go. State 3 results that are equivalent to the statement that A is invertible. A can be expressed as a product of elementary matrices. The reduced row echelon form of A is I, and the homogeneous equation A times X equals 0 only has a trivial solution. Nice. Must the inverse of an invertible symmetric matrix be symmetric? I believe so, yes. On that note, let's go ahead and grade what I did yesterday and then go from there. All right, so I can't grade what I did yesterday because Cloudflare is down, Cloudflare, and I needed to use Quizlet, and Quizlet's down. So I'll have to grade that problem from yesterday, and I'll just continue working on practice problems then from here. So talk to you in a bit. All right, I had a lot of time to work through these problems then since I didn't grade any. And so where were we? I'm definitely getting better at like the middle part of this transformation stuff. Transformation is now much clearer. You're taking one point or vector and you're turning it into another vector, and you say, how do you get the resulting vector from the original vector? That's the transformation. And we're talking about matrix transformation, which means multiplying by a matrix, standard matrix. Here we go. So 15 we finished up. So we had the standard matrix from yesterday. We wanted to solve via direct substitution. So we took this and plugged it into the original equations for the variables. It's got 3, -2, 3, and then by matrix multiplication or multiplication. So taking this as a vector times, or this as a matrix A times this as a vector ends up with the same, or this is a vector ends up with this as a vector. All right. That was 15. So next is 17a. 17a gives us a transformation here, and then it gives us an actual literal vector x. It wants us to first find the standard matrix, which I do by partitioning the standard basis vectors, and then solving for a, and then using a to solve for this as an x. So we say t of a, or transformation of a of x, equals, oh wait, I have to actually do it first. So the transformation of x equals standard matrix times the vector x, and that gives us that, and then check it via direct substitution. So plugging basically this as the value of x1, x2 into these, and getting the same answer. All right, 19. Transformation of a of x. I don't know how to exactly say it. Transformation a of x. So let me try to remember what we're doing here. It gives us a value of vector x to solve for. So plug it in, and it's given a standard matrix. I think you just have to solve it. That's pretty simple. Given a vector and given the transformation, and then write it as a matrix. I'm pretty sure that was it. And then 21 is what we're working on. It's saying use the theorem that proves transformation is a matrix transformation, meaning additivity property and homogeneity property have to be both valid, which is transformation of a vector, any vector u plus any vector v equals transformation of any vector u plus the transformation of any vector v. And then homogeneity property, transformation of the scale of any scalar k times any vector u equals any scalar k times the transformation of u. And so for currently I'm working on the additivity property. I've just defined any v, u, and k, a, b, c, d, e, and then we're going to take the transformation of a plus c, b plus d as part of this. This is this, simplified to this. And then I just recently, last thing I did was find the standard matrix to then work through proving that, or showing this. So that's it for today. Hopefully Cloudflare is back up tomorrow so I can grade my problem from today, or yesterday, I guess. So that's it for today. Talk to you tomorrow. See you.